Assalamualaikum and hello everyone. We are group at 002 to N1 from Chemistry 012. Today we are excited to present our assignment on application of acid and bases in daily life. Our team consists of Shakawi, Azkin, Wahida and Khatijah under the guidance of our lecturer, Dr. Anislo binti Muhammad Loh. We'll explore how acid and bases are used in products like milk, acid, soap and medicines. We introduce the main topic. Let us now proceed to the first subtopic of the presentation. A substance that produces hydrogen ions or hydronium ions in an aqueous solution. However, according to Arrhenius theory, say any species that increase the concentration in an aqueous solution. And then base. Base is defined as a substance that produces hydroxide ions when dissolved in an aqueous solution. But according to Arrhenius theory, base is any species that increase the concentration of hydroxide ions in an aqueous solution. Now, let's go to the next subtopic, which is the properties. To know physical, chemical, litmus indicator, and ions in solution. One is properties of acid. Acid typically have a sour taste and can cause a burning sensation upon contact with skins. Acid react with certain metals to produce hydrogen gas and undergo neutralization when they react with base. Turn blue litmus paper red and have a pH value of less than 7. In aqueous solution, acids ionize to produce hydrogen ions, which can also associate with water molecule to form hydronium ions. A common example from daily life is milk, which is a very weak acid. When it spoils after its expiration date, it becomes sour and curdled, indicating increased acidity. Next is the properties of the base. Bases typically have a bitter taste and feel slippery to the touch. Unlike acids, bases generally do not react with most metals. However, they undergo neutralization reaction when combined with acids, producing salt and water. Bases turn red litmus paper blue and have a pH value greater than 7. In aqueous solution, bases release hydroxide ions, which are responsible for their basic properties. A common example from daily life is soap, which is a mild base. Its slippery texture and ability to break down oils and grease are typically characteristic of basic substance. Now let's look at the empathetic nature of water. A substance is called empathetic when it can act both as an acid and a base. Water is a great example of this. This is water as base because hydrochloride is a strong acid and donate protons. Water accepts the proton to become hydronium ions. And this is water as an acid because ammonia is a weak base and accepts the protons, and water donates a proton to become hydroxide ions.
Assalamualaikum and hi, my name is Wahida Fatihah binti Adnan, and today I will present to you about strength of acid and base. Firstly, degree of dissociation is how much of substance splits into ion when dissolved in the water. Secondly, acid. For weak acid is molecules that partially dissociate into ions in aqueous solution. Double arrow is used, pH value is more than 7, does not release H plus ions into the solution, and it is a weak electrolyte. For example, phosphoric acid, carbonic acid. Strong acid is molecule that completely dissociate into their ions when it is in water. Single arrow is used, pH value is close to 1, does release H plus ions into the solution. It is strong electrolyte, and for example is hydrochloric acid, nitric acid, and sulfuric acid. For base is almost same like acid, but the difference is about the pH value. The pH value for weak base is close to 7, and for strong base is close to 14. And the example for weak base is ammonia and methylamine, and for strong base is sodium hydroxide and potassium hydroxide. Application of acid and base in cleaning products. Strong base like NaOH are used in drain cleaners, and strong acid like HCl is used to remove rust or scale. In medicine, help in choosing the right drugs. Some medicine work better if they are weak acid or base. Lastly, type of acids. For monoprotic is an acid that can donate 1 proton per molecule. For example, hydrochloric acid, nitric acid, and acetic acid. Next, diprotic is an acid that can donate 2 protons per molecule. For example, sulfuric acid, carbonic acid, and oxalic acid. Lastly, triprotic is an acid that can donate 3 protons per molecule. For example, phosphoric acid and citric acid. Type of bases. For monoprotic is a base that can accept 1 proton or provides 1 OH ion per molecule. For example, sodium hydroxide and potassium hydroxide. For diprotic is a base that provides 2 OH ions per molecule. For example, calcium hydroxide and magnesium hydroxide. Lastly, triprotic is a base that provides 3 OH ions per molecule. For example, aluminium hydroxide and ferric hydroxide.
Good morning and good afternoon, everyone. Today I'll be presenting on the topic of percentage dissociation of weak base and acids. This concept is a key part of understanding of how substances behave in solutions, especially in fields like chemistry, biology, and medicine. Let's begin with the definition. What is percentage dissociation? Percentage dissociation refers to the fraction of a substance, usually a weak electrolyte like a weak acid or base, that dissociates into ions in solution, expressed as a percentage of the initial concentration. This concept helps us to understand how much of the substance exists in its ionized form, which is crucial for reaction and biological processes. Now, what you guys are looking at is the formula of how we find the percentage of dissociation. Now, looking at the chemical reaction for weak acid, what is HA? Here, HA is the weak acid. It reacts with water to produce hydronium ions, and the conjugate base is A-. The percentage dissociation is calculated by comparing the concentration of dissociated ions to the initial concentration of the acid. Now, similarly for weak base, like ammonia, ammonia reacts with water to form ammonium and hydroxide ions. Again, percentage dissociation is the amount of base that actually forms ions compared to what we started with. This concept isn't just theoretical, it has real-world applications too, like medicine and pharmacology. The ionization of drugs affects how well they are absorbed by the body. For example, aspirin, the weak acid is better absorbed in the stomach's acidic environment where it remains mostly non-ionized. This form can more easily pass through cell membranes. Industry. Thank you for your attention.
Assalamualaikum and hi everyone, I'm Shakowi, and for the final part of our book assignment, I will wrap up our discussion on acid and base by highlighting their incredible roles in everyday products. Let's dive in. First, the pH scale helps us to classify substances as acidic, neutral, or base. Take a Greek yogurt. It's majorly acidic with a pH of 4.2 until 4.6 thanks to lactic acid from a fermentation. This acidity not only gives a yogurt its tangy taste but also supports digestion and probiotics. What is a Greek yogurt? Greek yogurt is a thick, creamy, and nutritious dairy product made by a stirring of regular yogurt to remove much of its liquid weight. This process gives it a richer texture and higher protein content. So now, how to calculate of a Greek yogurt? For example, I'm given a pH equal to 4.2. For example, I want to find the hydrogen ion. We can use the formula number 2. It is a hydrogen ions equal to 10 power of negative pH. If the pH you have to put is a 4.n, we have to get a 6.31 multiplied 10 power of negative 5 molarity. Now, what is lactic acid? Lactic acid is a weak acid, which means it's a safe consumption and even prevents harmful bacteria. It is a two strong acid like stomach acid, hydrochloric acid, or alkaline salt. Each plays a unique role. The next also is acid and base neutralization. So, what is the neutralization? When acid and base neutralize, they are formed of water and salt. This is how Antacids work. They use weak base like calcium carbonate to neutralize excess stomach acid, relieving heartburn. But remember, Antacids are a quick fix, not a long term. Titration is like a science seesaw. We have an unknown acid one side, we slowly add a base we know exactly other side. When it perfectly balanced is neutral, we calculate the acid strength. For our experiment, we simulate this by titrating antacids with hydrochloric acid and sodium hydroxide. The formula find the equation help us calculate how much acid was neutralized. Science in action. In conclusion, acid and base are everywhere, from cleaning products to food and medicine. They keep us healthy, clean, and comfortable. Understanding the mechanism helps us appreciate their impact on daily life. Thanks for watching. Don't forget to like and subscribe for more science content.